Hello everyone, my name is Pavel, and today I'm going to explain the LeetCode problem longest increasing subsequence. And in this problem we should find strictly increasing subsequence. Here we have an example, from that array the longest subsequence would be 2, 3, 7, 101. And here we should understand that it's not necessary that numbers in our subsequence should follow one by one. They could go through one, for example, as we can see here, 2, 3, 7, 101. And actually we got many subsequence here. So just for your understanding, for example, 9 and 101 as subsequence as well. So here we have also some constraints, and we understand that at least one number would be in our initial array, and for our numbers we could use simple integer. So how can we solve it? We can consider our initial array 10, 9, 2, 5, 3, 7, 101 and 18, and we would solve it by introducing dynamic programming and tabulation technique. So we introduce new array and fill all elements of this array with 1, just because elements of this array is a representation of longest sequence for certain position. For example, we fill all elements by 1 just because we know that each element itself is a subsequence with length of 1. So, and to solve and fill our new array with corresponding longest subsequence, we should go through the whole initial array from 1 to n, and in inner loop we would go through from first position from 0 to n, and we would calculate longest subsequence for that position. So here we have 9 and 10. We're comparing them. Just because 9 is less than 10, we just leave 1. After that, we will go to next position from 0 to second index. And we do the same, comparing 2 to 10. Just because 2 less than 10, we just remain with 1. After that we're comparing 2 and 9, and it's same value here, 1. After that we will go to 5 from indexes 0 to 3, and we're comparing to 5 to 10, 5 to 9, 5 to 2, and because 5 is more than 2, we just compare our current value 1 here, 1 comparing with the corresponding value from our initial array and our new introduced array, plus 1, just because we got a sequence here. So initial value, our previous element have 1 in our array, plus 1, and comparing with our current value at position with the value of element 5, it would be 1 plus 1. So we write here 2. You should understand why I'm comparing my current position and previous plus 1 here. So we go next. We do similar operations with the following element, and here we would have same value 2, just because 3 is more than 2. And here you should get and understand the main idea, 7. So here we find that 5 is less than 7, and that's why we're comparing 1 and 2 plus 1, and here we would have 3 2, 5, 7. And here we do the same, just because 7 is more than 3. And we're comparing 3 with 2 plus 1. And just because they are equals, we just remain 3 in that cell. After that, we will go to next position. And here we would have 4. And here we would have 4 as well. Just because our initial array could have some small value at the end, it could be 1. We just should go through our array and find the maximum value, so it's easy operation. So here it would be 4, and just because we iterate through our array and we have not only one loop, but for each position we going through the whole array as well, it would be a time complexity of n squared, and space complexity would be of n, just because we introduce new array with the same size similar to our initial one. So let's go to code and try to solve it. Okay, let's write some code here. First we create our array with similar length as our initial one. We fill initial value as 1 for each cell in this array. After we go through our initial array, and our inner loop, as I did in our explanation, would be from 0 to our current calculated position. And here, if corresponding cells from our initial array provide that our previous element is less than our current element, we just assign to our current position some value by comparing our current value and value of previous plus 1. So at the end we just go through our array and find maximum value. Initialize by 1. And return that value. So okay, let's check it. Okay. So okay, it's fast enough, and thank you for watching and have a nice day.